Hello. Uh, Hi, guys. Um, this is me again with a new question on gemstone hunt. So, this question was similar to the question that had been asked in Kickstart, a company from Google, where they ask you some questions, some tricky questions, such as this one. So, here's an interesting question today. Today, we're going to look out for the um, gemstone, which in case let's say if you have a certain gemstone, all right, let's say you have a gemstone, one gemstone has a power of 10, power level of 10, another gemstone has a power of 7, another gemstone has a power of 4, 6, 8, 10, and 11, and so on. So if you have same difference between the power level of the gemstone, um, then you would win. So, uh, in conclusion, you can see by solving this magical gemstone problem, you'll or Junes uncovers the forest secrets and gains newfound abilities. So let's go through this question once, okay? So Junes is an adventurer exploring a mystical forest. He discovers a series of magical gemstones hidden along his path. So each gemstone has a unique power level, which is a non-negative integer, and this was the power level that I was referring to earlier. And Junus wants to find the longest contiguous sequence of gemstone with the same magical power difference. Now, how do you go on by solving this problem? So as Junus explores, he collects magical power levels of each gemstone, which will be represented as an array of non-negative numbers, and we would want to find the longest contiguous sequence of gemstones with the same magical power difference. So they must be adjacent in the collection. So for each pair of adjacent gemstones, we will be calculating the difference and see if the difference remains same throughout this sequence. If so, then you get to win the thing. And the longest sequence of gemstone with the same magical power difference represents hidden enchantment in the forest. So um, I think we can just delve into this problem on how do we go on by finding the same difference throughout an array. Let's say we find some stones. Let's say one has 10, 7, 4, 6, 8, 10, and 2 and 11 and so on. So as you can see, I have the total length here would be 4, right? So if I somehow get this number, then I get some secrets and gain newfound abilities. So you might be wondering, where would we even use this kind of knowledge, right? So just imagine you're developing a game, and yeah. So one example would be developing a game where a character has to gather some gemstone, and if it has the same um, difference, then he gets some sort of abilities or and whatnot. So how do we approach this problem? Let's say mm, so the intuition and approach to this question would be to loop over the array and find the answer, right? So you just loop over to this array all the way till here, all the way to the end, and you simply see the length. So there are three things to maintain in this problem. All right. So the first thing would be maintaining the previous difference. Previous difference. So let's say in the first one, we'll have a difference of 7 minus 3, which will uh, oh sorry 7 minus 10, which will equal to minus 3, and see if this previous difference will be equal to the difference to the current difference. So the current difference here would be 4 minus 7, and so on. So this is the first thing that you will need to account for. Secondly, you will have to uh, maintain the current length, right? Current length, because initially you'll have a length of 1, and then if the difference between these two values are same, then you'll have different, the current length will increase by 2, and as you go on you'll see the difference is not the same, right? So here you'll have difference of 2, but here 3, minus 3, minus 3, so it will change here, it will return to 2. So the another thing that you need here will be to maintain the maximum arithmetic subarray length, right? So max length um, will be anywhere till AI, right? So initially the max length was 2, right? Now since it changed to 1 here, now this will, the length will just return 1 in this first case, and 2, 3, and 4. As you can see, the length here is, let's say, 10 and 7. So it was just 2. There are just 2 elements, so length would be 2. But here we have 4, so we replace this 2 by 4, which is our maximum length. So there are two cases to look out for. So two cases. Case one would be finding to see if the previous difference will be equal to area of I minus area of I minus 1. If this case holds true, then your current will increase by 1, and your answer would be the maximum of the previous answer and the current value. And another case, so this is case 1, and another case would be, what if the previous difference is not equal to AI minus AI minus 1? What if this is the case? Then we simply update the current answer to 2. As you can see, we updated here. We updated. It was the length was 2, but since we jumped here, the current would be 2 again, because of we have a length of 2, right? So let's go on by writing code, and then from there you'll get a somewhat understanding. And yes, so let's dive in. So for this one, we simply start by include, right, stream namespace c main. So in the end, and see out, enter the number of gems that are hidden in the forest. See in, and now once you you know, give n, what we would like to do is run a loop so that we can enter the uh, we can enter all the gems in this array, right? Int I equals to 1, I less than or equals to n, I plus plus. The out, enter the level of the gem mm, gem 1. So for each gem, it has a special power level, so that if the power level matches with the next one, we increment the current value by 1. So once, so this snippet here simply is the snippet to gather all the gemstone with different g- level, right? Different power level. Now, as I mentioned earlier, there are three things to maintain here. So, what are those? Those were the previous difference, current length, and maximum length, right? So, let's say previous difference. mm, let's initialize previous difference. PD equals to um, ARR, sorry, ARR 1 minus ARR 0. And let's say in current value equals to 2, because regardless of what values we have in the array, if there is 2, there would be two, at least 2, right? So the length would be 2 anyhow. And what do we need? We need max length, mm, inter um, so yeah, max length, which would be our answer, would be 2 again, because the current value is 2. So, and finally, let's initialize a pointer, which will also be 2. Okay. So mm, let's let's do it. Mm, while j is less than n, we would run a see if pd equals to arr j minus r j minus 1. If that's the case, then what do? We simply increase current plus plus, and yes, that's it. Else, what do? Um, the previous difference will be ARR j minus ARR j minus 1, and our current value will reset to 2. Yes. And now once that's been done, j plus plus, so that we can keep on looping the while, keep on doing the while loop until it reaches n. And then we simply say, what do we do here? Yep, answer equals to maximum value of the current and answer. And we return the value, see out the maximum length of the sub array is, what would we have? We would simply output the answer, and yep, and yell 0. Let's see if this code runs. What did we do wrong here? Oh, I didn't initialize that. Let's say, so enter the number of gems that are hidden in the forest. Let's say we have 10, 7. Now, let's use the same example as we have here in the question. 10, 7, 4, 6. 10, 7, 4, 6, 8, 10, 11. So as you can see, the maximum length of the subarray is 4. And that this is what we have here. So let's say, let's test one more time. Let's say there are about 10, about 10 gems, and first gem would have a power level of, say, 7, 3, 1. And let's have the total length of 5, all right? So in that case, the difference between 3 and 1 is 2, minus 2. So, okay, I need to keep on increasing because we need positive number. So let's say, how about start by saying 1 again, 2, 3, 4, 5, and let's say 7 and 3. So yeah, as you can see, we have 5. We have the length of 5, right? So that would give me certain abilities, because this is what we find, right? So let's say the length is 2. 2 would give certain abilities, 3 would give another abilities. So depending on how many consecutive numbers that you find, the power level depends on that. So yeah, this is a kind of really interesting question, which is which would be helpful in developing games. So in those games, you could make certain program that would give you this